Okay, so this is section 1.4, and it's application oriented, equations of lines. So doing equations of lines, and we're going to try to focus on the real life word problems. We're not going to do every slide. We don't necessarily need to. Everything matters about the context anyway. So if you're going to call the plumber, be prepared to take your wallet out. It's going to cost a bunch just to even call for service. It's going to cost 65 bucks, and then it's $30 per hour. Actually, these are really prices. I'm sure it's like double by now. So anyway, you can make an equation in y equals mx plus b form right here, where the unit rate, the slope, this thing that's changing is the number of hours, right? So the cost, y, depends on x, the number of hours the plumber comes out. All right, so keep that in mind. So even if you just call and doesn't even do any work, it's cost $65. So be really sure that you want the plumber to come. All right. So this is called point slope form of equation. I'm not going to quiz you specifically on that. Again, this is equation. This is application oriented, but I'll just point out sometimes it's convenient to use this point slope formula. It's when you have a point. X1, Y1 is the point. X stays the same, Y stays the same, and M is the rate of change. All right. So again, we'll do this in class if you want to know specifically. It's just the background material, but it's not directly related to our word problems. It can be a helpful tool to get there, and we'll do that when we arrive inside that problem. But we're not going to do it just in isolation here. But basically, the x1's -4, the y1 is 6. So if we know the slope, we can write the equation of a line, y minus 6 equals 1/4 times x minus x1, which is -4. So you can write it in slope-intercept form. That's what that's for. Okay? But let's go into a real problem here. Now, blood alcohol content. Oh, yes. So this is talking about the number of drinks somebody has. Well, actually, an 180-pound man has, and the blood alcohol level. Okay. So this right here table gives the drinks. Okay. So one drink, and they talk about the different kinds of drinks that are equivalent. Okay. So legal rate is 0.08% blood alcohol level. All right. So take a look. Is the rate of change of the blood alcohol percent for 180 pound constant? That means that if you go up by one drink, does the percent body alcohol level go up by the same amount? Yeah, it goes up by 0.02, 0.02, 0.02, 0.02. So it seems like every drink, and this is what they consider a drink. Okay, different types. It is constant. It goes up by the same amount. Write an equation of the function that models the blood alcohol content. Okay, so that's going to be y is equals. Now, what's the rate of change? Right, 0.02x. Right, so for each drink, x, this blood alcohol level goes up by 0.02. And I guess I have to take that back, right? Because two drinks would be 0.05. Actually, no, take that back. All right, so rate of change. What's the rate of change? We got that already. But we need to find the y-intercept, right? So we'd have to substitute in. So we can put in one of these values, put in a 3 in here, and we get 0.06. 0.06 plus what equals 0.07 down here. So it's got to be 0.01. So you can use your algebra skills to work backwards to find out what the slope intercept, the intercept is. Well, if you just go back 0.02, 0.02, 0.02, you get to 0.01 anyway. Or you can substitute 3 and 0.07 into here to find this right here. All right? Just keep that in mind. Save. Sorry, I skipped. There we go. So they use the point slope form. You don't need to use that. But we got the same answer doing the our way, so don't worry about the point slope form. You can get away without doing that. Equation of the line. All right, so here's a real life problem. Here we go. Because it's all about the application. That's what matters here. All right. The number of people in millions, okay, in U.S. prisons, jail, grew at a constant rate. So basically, from 2001 to 2013, the number of millions of people in jail have increased. With 1.35 people incarcerated in 2011 and 1.57 incarcerated in 2013. So what's the rate of growth? So they want slope, okay? So what's happening here? You're going from 1.35 to 1.57. So I would do vertical change 1.57, right? Minus, this is a million by the way, 1.345. Vertical change, okay. Okay, so that's vertical change, right? Over horizontal change. What's the horizontal change? It's going from 2011 to 2013, so it's 2 years. So there you go. So it's 0.165. Oh, they went from 2011 or 2001. I guess that was a mistake. I think this is a typo because this says this is 115 and incarcerated in 2013. I think this is supposed to be 2001. I think that's a typo. So we'll go back and we'll change that. Okay, to 12. Okay. Still not matching. Let's see here. Oh, 1.345. What the heck was I doing? I think I mistyped a number. 34. There we go. So just be careful when you're typing it in. That was a typo there. That was supposed to be 2001. And I was just typing in the wrong number there. So that wouldn't help. So therefore, what's that saying? That's the rate of change. That's the slope. So I'm missing a zero also, aren't I? 1.570 minus 1.345 over 12. That's a mistake also. Should be 0.0187. That's a mistake. This is correct. All right. 0.01875. That's the amount of people in millions who are being incarcerated every year. That's an error. Okay, here we go. The number of people. Okay, we did this already. They're just working out the algebraic steps. We can do that in class if you wish to. Yeah, see those are mistakes. See, they got it right now. We were right. See this right here, 0.01875. So we knew we had it right. What do they want to know? They want to use this function to predict the inmate population in 2017. So if we know the rate of change, so we can write the equation. We could say y equals the rate of change, the slope is 0.01875. Now, x stands for the number of years since 2001. Be careful here. Of course, it would be, I guess we're going to say 2007. Sometimes, usually x stands for the number of years since, but it doesn't say that in this problem, so we're going to put 2017 in. And then plus, what do we want to add? We don't know how many were incarcerated in 2001. 1.345. The y-intercept. Let's see what's different here. Oh, we didn't do the y-intercept. Okay. So from the previous problem, we needed to find the y-intercept. We knew it was y equals mx plus b, but we need to find out b. So what we do is we just plug in one of the points that we know. We know that in 2001, it was 1.345, and x was 2001. So in order to get that in there, we need to multiply that times that, and then find out what that number is. So that means that we're going to have 0.01875 times 2001, and we get that, and that has to be subtracted from 1.345. So plus what? So it's got to be 1.345 minus that number. So it's going to be 1. In order to get 1.345, and from 37.6, we have to subtract. Okay, so in order to, right? Because 1.35 is equal to something plus something, right? Well, if you already had 37, what do you have to do to 37 in order to get 1.345? You have to subtract. So It's going to be 1 minus 37.51875. There you go. So that's the y-intercept. So negative 36.17. So therefore, we can finish that previous problem when they said with 2017. It's going to be y equals. So the number we're looking for is equal to slope 0.01875 times 2017, and then you have to subtract the add the y-intercept, conclude the y-intercept plus the 1 plus b, but b is negative. That's why it looks confusing. 37.1735. You see you get 1.645, and that matches what they have over here. So that's how you do that. You do that on paper. I just don't want to futz around having another application on my computer right now. So that'd be a little bit too much. But you see it's 1.645. That's the number of millions of prisoners that are predicted in 2017 based off of this. Now the key parts were finding the slope, which we did earlier, and then we plug in a point that we have defined in the b. Okay, so y equals mx plus b. We put in a y and an x. I chose 2001 and 1.345. You could have chosen 2013 with 1.57 and gotten the same answer. Moving on. Okay, so horizontal and vertical lines, one variable is 0 and the other one is not. We talked about that. Slope is 0 is horizontal. Write the equation of a line. You're not going to really have to, let's wait until we have to do that in context. Otherwise, it's kind of necessary when it's necessary. You know what I'm saying? So x equals the number is a vertical line. Y equals the number is a horizontal line. X equals the number is a vertical line. Y equals mx plus b normally is a diagonal line. That's the key. The key shapes. General form of line is when we have x and y like that, but we'll wait to do that until we get a real life problem that we have to work on. Rate of change. Another way to say rate of change, yeah, again, change in y, a vertical change over a horizontal change. That's what I told you. But you could also say change in y over change in x. Okay, change in output over change in input. These are all ways of saying the same thing. Okay, so the average rate of change is equal to average change in y over change in x, horizontal change over vertical change over horizontal change, or change in y over change in x, vertical over horizontal, y over x, output over input. All ways of saying the same thing. Okay, so here's an automotive example where they give you a big messy function. You can type that into Desmos right here, and then it's saying the number of Teslas. So the number can be modeled by, so the number of Teslas in thousands can be modeled by number of years after 2010. So X stands for the number of years after 2010, and S of T, or Y, stands for the number of Teslas made in thousands. So they want to know, what do they want to know? They want to know what's the rate of change. What's the rate of change between 2 and 6? So in 2 years after, what year was it? 2010. So in 2012 and 2016, what's the average number of cars being made per year? All right, so you put S equals 6 here, X equals 6, you get 99.28. You put X equals 2 in here, and you get 1.896. You can do this on the TA84, or you can do this in Desmos. I'm doing it here for you. So the vertical change, 99 minus 1.86, you'll do that and you get 97 right here. And then you do 6 minus 2 and you get 4. It's right here. And you solve that out and you get 24.346. You can do that right here in Desmos. Desmos is a regular calculator as well, so you can type that in there and find out that answer. It's there. All right. So the average number will be about 24,000 cars made per year during 2012 and 2016. All right. And why those years? Because that's the number of years after 2010. All right. So that's how you use that. So again, Desmos is a regular calculator, so you can do this. You could say, okay, 99.28 minus whatever that was, 1.896, just so you can see that how it works, divided by, and then you say 4, and you get the same answer. Okay, so Desmos works the same way. Come back in a little bit.